Math lesson number 17, Relations and Functions. A relation is a set of one or more ordered pairs. A relation can be described through a set of ordered pairs, a table, a mapping diagram, a graph, or an open sentence in two variables. So these are examples of relation. So because a relation is a set, we name a set by a capital letter. So A is equal to that one. So these are the elements of the set, which are ordered pairs. Okay. So those are examples of relation. So the elements are ordered pairs. Now let's have sets A, C, and E are special relations called functions. Why? Let's have the definition of function. Function is defined as a relation such that for every value of x, there corresponds a unique value of y. So there must have one value of y for every x. So let's have B. Let's see B. So as you can see, if this is x, this is y, this is x, this is y, 2 has two values of y. So as you can see here, the value of y here is 2, the value of y here is 3. And then this one, the value of y is 4, and then this one, the value of y is 5. So x has 4 values of y. So this is not a function. A function must have one value of y for every x. So now let's take a look at relation D or set D. This is 1, 2, and as you can see, this is 1, 5. Therefore, the x value of 1 has two values of y. So we have here 2 and then 5. Therefore, that's not a function. Now let's take a look at A. So this is 1, 2. If x is 1, y is 2. If x is 3, y is 1. If x is 2, y is 4. And if x is 4, y is 5. And then for C, same thing. And then for E, same thing. Therefore, sets A, C, and E are considered as function. Because again, for every value of x, there corresponds one value of y only. Now let's have this one. All functions are relations, but not all relations are functions. So take note of that. Let's have this one. There are different ways of looking at a function, and here are some pictures to illustrate them. First one, using a mapping diagram. So this is how you're going to have a mapping diagram. So let's take a look at this one. This is what we call a one-to-one relation. Why? Because for every value of x, there corresponds one value of y. So 1x, 1y. 1x, 1y, and so on and so forth. That's why it is called one-to-one relation. And this one-to-one relation is considered as a function. Why? Because for every value of x, there corresponds one value of y. Now, since this is a one-to-one relation, this is a function, we can consider this as a one-to-one function. Let's have this second diagram. So as you can see, many values of x correspond to one value of y, which is -2. So this is a many-to-one relation. And many-to-one relation is a function. Why? Because for every value of x, there is only one value of y, which is -2. So 2, -2. 3, -2. 4, -2. There's only one value of y. So this is a function. Let's have the third diagram. only one value of x, but many values of y. Of course, this is not a function. This is what we call a one-to-many relation. Take note, a one-to-many relation is not a function. Just take note of that. Why? Because x has many corresponding values of y. In order for this to be a function, there must be one value of y only for every x. Let's have the other one using vertical line test. So, to determine if a relation represented by a graph is a function, use the vertical line test. If a vertical line drawn in any part of the graph touches at exactly one point of the graph, then the graph represents a function. Let's have this example. So this is a parabola that opens upward. So if you're going to use vertical lines, that one, let's take a look at this vertical line. It touches only at exactly one point. This one exactly one point, this one exactly one point, that one exactly one point. Therefore, this is a function. Let's take a look at this parabola again that opens to the right. If you're going to draw one vertical line, it touches 2 points of the graph. Therefore, this is not a function. It must touch 1 point only to be considered as function. Okay, so therefore this is not a function. Let's have this circle. This is a vertical line and it touches 2 points of the circle. Therefore, this is not a function. Let's have this wave graph. If we're going to use vertical lines, that one, this vertical line touches the wave graph at one point, this one at one point, this one at one point, that one at one point. Therefore, this is a function. So that's how you're going to use vertical line test in determining if a relation represented by a graph is a function. Let's have independent and dependent variables. In an equation involving two variables, when we input a value for a variable, let's say that's the first variable and that is usually x, and get an output for another variable, the second variable, that is usually y, the first variable x is called the independent variable. And the second variable y is called the dependent variable. Now we choose a value for the independent variable and solve the equation to get the value of the dependent variable. So again, we choose a value for x, which is the independent variable, and solve the equation to get the value of y, which is the dependent variable. So let's have this example. In y is equal to 3x minus 7, x is the independent variable. So because we input values in x, or to substitute x, and y is the dependent variable because we need to simplify that. We need to evaluate that, and the result will be y, and that y is the dependent variable. So in short, y depends on the value of x. That's why y is the dependent variable. As simple as that. Now let's have domain and range of the function. When we say domain, it is the set of all the values of x in the function. When we say range, it is the set of all the values of y in the function. So let's have example. State the domain and range of the function. 0, 4, 1, 5, 2, 6, 3, 7, and so on and so forth. So because domain is a set, we will write this in this form. So 0, 1, 2, so these are the elements because these are the values of x. And range is a set also, so we will write we will write range in this form. 4, 5, 6, these are the values of y in the example. So this is domain, this one is range. Now let's have another example. Give the domain and range of the linear equation y is equal to negative 4x minus 2. So the domain here is x such that x is a real number. Why? Because any real number can substitute the value of x here. So you can substitute any real number for x. That's why the domain of this function is any real number. Now let's have the range. Range is y such that y is a real number. Why real number? Because if you're going to substitute real number for x, the result is also a real number. That's why y is any real number that depends on the value of x, which is a real number also. So the range of this function is any real number. Let's have the last example. Give the domain and range of the equation y is equal to 1 over x minus 4. Now the domain is x such that x is a real number not equal to 4. Why not equal to 4? As you can see, if the denominator of this is 0, then y is undefined. Y must not be undefined. That's why the restriction there is x must not be equal to 4. Again, if x is equal to 4, then the denominator becomes 0. If the denominator becomes 0, then y is 1 over 0 or undefined, which must not be. Therefore, x is any real number not equal to 4. So you can substitute any real number except 4 for x. Now let's have y. Y is any real number. So as you can see, if you're going to substitute any real number for x, as a result, y is also any real number or a real number that depends on the value of x, which is a real number, except 4. Therefore, the range of this equation is y such that y is a real number.